Hey there, welcome to dotnetFlix. So in today's episode, we are talking to Tom van den Berg. And the last time we spoke with Tom, we talked about how to get a grip on your non-functionals using Azure load testing. And today's episode is kind of a continuation of that conversation, isn't it, Tom?
Yeah, it is. So last time we talked about Azure load testing, and it's finally GA at the beginning of this year. It's globally
Yay.
available, general available. So um, I actually took it to the next level and have a really cool demo for you guys today. So
Cool.
we should
Sounds
definitely
good.
dive into it, I think.
Yeah, let's go.
Yeah. So last time we talked about how you could get grip on your non-functionals, or how you could get grip on your performance non-functionals, to be more precise. But today I want to take you guys further down lane, what's even more possible with your non-functionals, namely continuous validation. Did you guys ever heard of the term continuous validation?
I haven't yet, so I'm
No.
really curious about it.
Yeah, so the first time I ever heard this phrase, continuous validation, was in an Azure Friday podcast from Scott Hanselman. And he talked to some guys at Microsoft that are working on the mission critical part of Azure, namely how businesses can use Azure to run their mission critical workloads. Continuous validation is one of the steps in their CI/CD process that they use to verify their actual mission critical non-functionals. So last time we also looked at this circle, I think, or is it new for you guys?
I
Not really
think you
sure.
showed it last time, yeah.
Sure. So last time we talked about like performance and scalability testing. So today I want to talk to you guys about the reliability testing. So let's dive in. Reliability engineering, when you Google it, you usually get the phrase, or you will find easily the phrase of chaos engineering. So you guys are familiar with chaos engineering? Netflix
Chaos
invented it.
monkeys, right?
Chaos monkeys.
Simian Army, Netflix, all
Yeah,
that kind of stuff.
yeah, for sure. And the most important thing one of the most important things of mission critical applications. So I work at the Dutch Railways, where we work on a mission critical application. And one of the highest concerns that they have is that our system doesn't work. Because when the system isn't working, the trains are not able to ride, and passengers won't be able to get home, and the NS is not going to make any money. So since the outage of like April last year, where we had this Sunday where no trains were able to ride, that since then the NS is actually looking into chaos engineering and even more at their non-functionals and how they actually can improve them. So chaos engineering is a process where you can create chaos in your system and see how your system reacts to it. And the way of work of how you can do it is like you first start with an hypothesis, like what would happen if we pressure the CPU to like 90%, or what would happen if we restart that Redis cache, and should the system be able to survive that? Should there be an outage? Is that a problem or not? First start with hypothesizing about what could go wrong and is it a problem if it does. So the next step is that you actually define the experiment that you want to do. So like I want to pressure the CPU to like 90%, or I want to restart all my pods in this namespace if you use Kubernetes, for example. What would happen, and is the system able to to restore itself to normal use? So then you start experimenting with it. You actually are going to run the experiment. And Azure has a new, kindly new, it's been around for like 1.5, maybe 2 years already, but it's still in preview. That's called Chaos Studio, that you can use to run these experiments with if you have an Azure-based application. So the next part in this circle is that you then are going to analyze the results. Does the system have any outage? Was it expected? Was it enough for us? Was it acceptable that this happened in this chaos, and then define the next step to improve. The system didn't respond like we expected it to, or it did respond like we expected it to, but it shouldn't respond like this. And then you can take steps to improve your system, and then run the hypothesis and the circle again to verify that you actually improve the system that you built. So if you guys look at this landscape, a simple Azure landscape with an app service, what would be, if we hypothesize of what would go wrong in the system, what would you guys say that could happen, that you would like to test?
So where do we start? A lot of things can go wrong in this picture, I think, Tom. But so let's say a database goes down.
Yeah, that was exactly what I would want to say. Tear down the database.
Yeah, for example, database could go down.
And also kill the DNS server, because it's always DNS.
It's always DNS. That's my third circle. That's my third circle, actually. But also, what would happen if my key vault isn't reachable anymore?
Mm-hmm. Yeah.
Did we code the system correctly that it doesn't require key vault to be online or to be reachable for the system to work normally? And of course, DNS. That's something that always, I had an experience with it yesterday as well. Let's not dive into that. But yeah, you first start with hypothesizing, what could go wrong? And the next step is we are actually going to create the chaos and actually are going to stop that database or kill the DNS server or do whatever we want. And for that, we can use the Azure Chaos Studio. It's still in preview. And it's an experimentation platform for improving your app resiliency. So,
Tom, a question: are you actually going to bring down the database, or are you going to simulate this by maybe blocking network traffic or whatever, or is it actually tearing down services?
That actually depends on the chaos that you want to create, because there are two types of chaos. Like my first bullet here says, there are two different types. There's the real chaos and the simulated ones.
Okay.
And the real chaos is actually, for example, used on a VM when you want to pressure your disk or your CPU to like 90% or 100. Chaos Studio will actually install an agent on the VM that's going to pressure your CPU. So that's real chaos that's going to happen.
Yeah.
And there are other, for example, DNS is one that's simulated by the Azure network. So it depends on the chaos that you want to create, if it's real or simulated.
Makes sense.
Yeah, so this also fully integrates with your test engine, which means that you can actually, for example, use managed identity to access your resources, or you can use, what would I say with this? Well, let's dive into what Chaos Studio actually does for it, and then if you have any more questions, then we'll have a look. This is actually also the tooling that the engineers at Microsoft use to verify their own creations, to verify their own services that they provide to us and to the world. They actually use Chaos Studio and tools like this to make sure that the systems work the way we expect it to be. Yeah, so let's dive into Chaos Studio. So last time I had this API that had a Cosmos DB behind it to perform the load test on and identify where the bottleneck was. So now I have this new application. It's just a simple Nginx container that's running in my Kubernetes cluster. And I'm clicking on the wrong screen. So like that. So let's dive into Chaos Studio. It's not something that you need to create. So if you just go to the home of the Azure portal, and then you can just search for Chaos Studio, and you can just open the Chaos Studio. There are two different main things within Chaos Studio, and that's the target. With a target, you actually make a resource that you created in Azure, for example, my AKS cluster here, and make it a target of my chaos, which means that I'm not able to create any chaos in any system that's not targeted. So I have to be sure, and I have to be fully aware of I'm making this resource a target of my chaos. And within this resource, you can manage the actions that you have in it. And with this, you can actually select the capabilities that you want to give to your target. So it doesn't, you just don't just say, hey, this is a target for my chaos, but you can also fine grain the types of chaos that you want to allow the target to be created. Yeah. Any question about that for now? The target? I'm fully. Do you guys understand what the target is?
Yeah,
Pretty
makes
clear.
sense.
So then we go to the cool part, and that's the experiment part. So there are a lot of experiments that you can create, but first we look into this really new feature, and that's that Azure is also creating templates of chaos that you can take off the shelf, that you don't have to perform any configuration for. They just give it to you and you can start. So it's a very low effort to get started with chaos engineering nowadays. And for example, there are only 2 templates for now. That's an AAD outage. Well, what would happen if Azure Directory goes down, Active Directory goes down? Well, at the Dutch Railways, I know no one can actually log into the system, so that might be a problem. And what would happen if an availability zone goes down? 2 templates that you can use out of the box with your system to test how it works. There are a lot of more different types of chaos that you can create. So let's skip this. Well, like I said, there's a fully integration with Azure Security, so you can use Managed Identity as well to access your resource. And then you have the Experiment Designer, which you can use to create your experiments with, like the one that we just set in the chaos way of work circle, the experiment part. And here you can add faults, like they say. You can add the chaos to your experiment. And the list of chaos that you're able to create is very long, I think, for now, for just something that's still in preview. But you can, for example, say from, hey, what would happen if my Cosmos DB does a failover? Or what would happen if my DNS failures render for you? If you would like to test tomorrow on your system, that would be fun, I think. But also network disconnect or firewall rules or security rules that are changed, modified during runtime of your service. A restart of is somewhere in here. Restart of the Redis cache is also somewhere here. Oh, here, cache for Redis reboot. What would happen then? And there's this thing called Chaos Mesh. And Chaos Mesh is an open source chaos engineering platform that you can install in your Kubernetes cluster. And Chaos Studio actually integrates with Chaos Mesh to create chaos inside of your cluster as well. So you can actually say, hey, there's this mesh network issues, or there's some DNS issues within AKS. You can actually, perform really cool chaos as well.
So does that integrate with Chaos Mesh, as in you first have to install Chaos Mesh inside your own AKS instance, or does it also install Chaos Mesh into your Kubernetes environment?
No, I first had to install Chaos Mesh inside my cluster.
Okay.
So then it integrates with it.
Yeah.
So yeah, that's actually what Chaos Studio does for you. When we go back to the slides here, the demo we just did. So when we talk about continuous validation, because we just only talked about chaos engineering, what it is. When we talk about continuous validation, you actually combine Azure load testing and Chaos Studio inside of your CI/CD pipeline to make it a fully integrated step in your pipeline. So first, you start your pipeline, you build the stuff, you test the stuff, and then you deploy it to your environment. And then you can actually start running not just your load test like we talked about last time, but also integrate chaos during your load test to identify not just how does the system perform under normal circumstances, but how does the system perform under chaos circumstances? How does the system, does my region failover, or does my scaling mechanism, or does my whatever you put in place to prevent chaos, is it actually set up correctly, and does the system react like it should? So that's actually what chaos of continuous validation is. To see it in action, we go to my GitHub. What I did is I actually created a GitHub action that has this continuous validation step. And what this actually does, it just logs into my Azure, then it starts a chaos experiment. And it's really important that we first start the experiment before we run the load test, because the chaos experiment isn't an awaitable thing. It just starts the experiment and then comes back to my CI/CD pipeline and says, hey, you can continue to the next step. It doesn't have any outcome or so. It just creates chaos, and then you should do something else with that chaos. So I added a load test after the chaos, or during the chaos actually, to identify that the system actually can live up to the expectations and live up to my non-functionals, even under chaos circumstances.
So where do you define how long the chaos experiment should run?
Yeah. So what I did for that is I see that my Visual Studio is not really okay. This is in my infrastructure. So it's all in my infrastructure as code. I have this management and governance chaos experiment. This fully bicep. I don't know why my highlighting is working, but you can actually define the chaos experiment within your Azure, within your infrastructure. So I fully, there it goes. I fully created this by infrastructure as code, and I actually define my duration within my infrastructure.
Right.
So yeah, let's see it in action, I think. Cool. So what I did here is, I should run this load test first. Deploy. So this is just a normal load test that we talked about last time, and now it's gonna run. I'm not gonna wait for that, so I will start the other one later. But here I have the outcome of my. Let's first look at the normal load test to actually see that there is something that's happening, because under normal circumstances, my error rate and my response time was normal, was expected, was living up to my expectations from my non-functionals. The second step, in my continuous validation step, you actually see that I started my chaos experiment. It just runs, it starts, and then comes back. And then it runs my load test. What you see here is that the numbers have changed, because my average response time wasn't at 1 point something that it was last time, but it was now going up. It's almost 5 milliseconds. It's still really fast, but could be that my non-functionals aren't met for this. This is also interesting. My error rate, because the last time it was 0, now it's 1.9, almost 2%. So it's not really a large increase. Well, it is, because if you look at the total requests that's done by my load test, it actually says it has done like 10 million requests, I think, and almost 20,000 of them failed, which in relation is almost 2%, so it's not really much, but the difference is really there. And you see that when there's chaos in my cluster, there is actually something happening, and the system isn't responding to it. It can handle it because my non-functionals are still met, but we do see that there are errors occurring. But for now, I say in my non-functionals, hey, I accept this. I accept an error percentage of 10%. So 2% is acceptable.
And Tom, what is the action that you're actually executing now as chaos? I guess it was part chaos. And can you tell us what that is?
Yeah, so the chaos experiment that I created is the one that is a really simple one. I have I hope it says here. Let's go here. So I have 3 containers of Nginx running in my AKS cluster, and I actually say here, hey, I want some pod failure. I want my pods to crash. I don't want them to be able, and I want it to be 2 out of 3 in this specific namespace. So 2 of my 3 containers are going down for like 2 minutes. So the system only runs on 1 leg instead of 3, like it should normally do.
Yeah.
And then you see that the error rate is going up because the system can't handle the amount of requests it's getting in the same time as it normally should.
Yeah. That's why you had 3 in the first place, right? To get all that requests handled correctly.
Yeah, to actually, if I go back to this one, to actually make sure here, almost those 1 million, or what is it? Yeah, 1 million requests, there are no errors in there.
Yeah.
And when it goes back to 1 leg, there are errors.
Cool.
So yeah, that's actually what I wanted to show you guys today about continuous validation. But now you might think, hey, how can I use it? When should I use it? Or what are even the costs for it? So let's have a look at that. So when should you actually use continuous validation in your pipeline, or should you integrate it? Well, we at the Dutch Railways are integrating it because we are developing a mission critical system where the non-functionals and the availability of the system has this higher need, that we want to make sure that every time that we release our software, it doesn't influence our non-functional, so that the system can always be resilient against the chaos that might occur in our system. Should you use it on your own system? Well, it depends. It's the classical answer, I would say. But it depends on which type of system that you're actually building. If you're building a small IT, small software for the local baker, you should definitely not include this. But if you're running or creating a mission critical system like we do at the Dutch Railways, you should definitely look into this. So it should always be, it depends situation on your specific situation. So the cost for it, you might think, how expensive could this be? And that's also the answer, it depends, because it fully depends on 2 things actually. How long your chaos experiment actually runs in your system. So how long is the Azure actually creating chaos in your system? That varies the cost. And also the load test varies the cost, because when you use the load test and the test engine, like I told last time, there are also costs related to that. So if you run a longer test, you should have a bigger wallet, because the costs are going to increase kind of steep. So it actually really depends on what your use case is. And the environment where you should use it in. Well, I'm a big fan of testing in production. If you do this the first time, I would definitely not recommend that you test in production, because you might break something that isn't really expected. So you should definitely first start with your first experiments on your acceptance environment, I would say. If you have the confidence and your system has grown and you can perform these experiments on your acceptance environment without any issues, I would definitely recommend to try it on the production environment, because production is the only environment where it actually counts, and where the requirements are actually the most important, that they are correct. So you should definitely try it in a production environment if you have enough confidence about how the system actually works. And for those who don't think continuous validation is anything that they want to include because it's not really necessary for the system they are building, you should definitely try it out at least once, just to experience what it's like to create chaos and see how the system reacts under this chaos, so that you can actually see what is your level of availability, what is your level of whatever, and is that acceptable for your use case? So in short, everyone should try it at least once, but should you fully integrate it into your pipeline? That actually depends on the situation that you actually have. We're currently within the Dutch Railways actually implementing this for new services that are mission critical and are making sure that the trains can ride and bring everyone home each day.
That's pretty nice.
Yeah. If you guys want to get started with this, I'll just give you a quick reminder. I just had this issue last week. So when you deploy your Azure load testing resource, there is this action that I'm using. But this action is using the data plane of Azure, which depends on the synchronization on the backend of Azure to make sure that the system knows that all the resources are there. And there's now this bug that Azure load testing resources aren't directly available in this data plane. So if you start using this, just give it some time to synchronize. By the end, I had to wait like 30 minutes or like almost an hour to make it fully synchronized. So it does work, but you
be patient for the chaos.
Yeah, only the first time. That's because when you created it, then after that, it recognizes it and you can actually use it more.
Oh, that's a good to know.
Yeah. Okay, well, thanks, Tom, for showing us this. I think it's a really nice way that you can use this tooling, and it's also pretty visual, right? You can design your experiments and everything, but you can also then just kick it off from a CI/CD pipeline through Infra as Code. So I think that's a really good way to do that. So thanks for showing that. I guess you have a GitHub repository. Is that also available for people at home? So we can share the link?
Yeah, for sure.
Okay. Yeah. I will put the link I'll put the link in the notes, so in the show notes, so people can get to the repository. So thanks for watching, everyone. If you like dotnetFlix, please subscribe to our channel, and we hope to see you at the next episode. Bye-bye.
Bye.